Imagine a place in the universe where time stops, where light itself cannot escape, a place where the very fabric of reality bends, and the known laws of physics collapse. Welcome to the darkest secret of the cosmos. Welcome to the black hole. For centuries, humanity has gazed at the night sky in wonder, but hidden among the stars are invisible monsters, mysterious regions of space that devour everything in their path, even light. Today, we begin a journey beyond the event horizon, a journey to uncover the dark secrets of black holes. But what exactly is a black hole? To understand it, we must first go back to the death of a star. Picture a star many times bigger than our sun. For millions of years, it burns brightly, fusing hydrogen into helium, creating energy, light, and heat. But one day, the fuel runs out. Without its fiery core, gravity takes over. The star collapses under its own immense weight. For the largest stars, this collapse ends in a cosmic explosion, a supernova. The outer layers blast into space, but the core continues to shrink, smaller and smaller, until it becomes something extraordinary. A region of space so dense, so powerful, that not even light can escape. This is a black hole. Visual prompt. A star explodes in a brilliant supernova. The core shrinks, darker and darker, until only a void remains. Surrounding every black hole is a boundary, known as the event horizon. This is the ultimate point of no return. Cross it, and there's no way back. Not for a spaceship, not for a planet, not even for light itself. The event horizon is not a physical surface, it is an invisible boundary to the outside universe. What falls inside simply disappears. But what would it be like to approach this deadly frontier? Imagine flying a spaceship toward a black hole. As you get closer, its gravity stretches space and time itself. From far away, observers would see your ship moving slower and slower, as if time itself had frozen at the horizon. But for you, inside the ship, time would feel normal. You would cross the boundary without noticing. Yet in that moment, you would vanish from the universe forever. And before we cross into the next chapter of this cosmic journey, if you're fascinated by the mysteries of the universe, don't forget to hit that subscribe button. Your support helps us keep exploring the cosmos together. What happens if you fall inside a black hole? The answer is terrifying. Near a black hole, gravity isn't the same everywhere. The pull on your feet could be millions of times stronger than the pull on your head. This difference creates what scientists call tidal forces, and the result, you would be stretched, pulled, and torn apart into thin strands of matter. Scientists call this spaghettification. Yes. If you fall into a black hole, you become cosmic spaghetti. For an outside observer, however, something strange happens. They would never see you actually fall in. Instead, they'd see your image frozen at the event horizon, slowly fading away as the black hole devours your light. But inside, for you, the journey has only begun. One of the strangest effects of a black hole is how it bends not just space, but time itself. Einstein's theory of relativity tells us that the closer you are to a strong gravitational field, the slower time moves for you. Near a black hole, this effect is extreme. Imagine orbiting just outside the event horizon. For you, maybe only a few hours pass, but for people far away, years, even centuries could go by. This means a journey near a black hole could be like traveling into the future. What if humanity one day used black holes as time machines? Could we really skip forward in history just by hovering near these monsters of gravity? The truth may be stranger than science fiction. At the very heart of every black hole lies the most mysterious concept in all of physics, the singularity. It is said to be a single point, a place where matter is crushed to infinite density, a place where the laws of physics as we know them simply break down. Our equations fail here. Gravity becomes infinite. Space and time cease to exist in the way we understand them. But is the singularity real? Or is it simply a sign that our science is incomplete? Some scientists believe that quantum mechanics, the strange laws of the very small, might rewrite the story. Perhaps the singularity isn't a point at all, but a hidden region we cannot yet see, or even a gateway to another reality. The truth is, we don't know. The singularity remains the darkest secret of the black hole, and the greatest challenge to our understanding of the universe. But what if black holes are not just destroyers, but portals? Theoretical physics suggests a tantalizing possibility: wormholes. Imagine space as a vast sheet of paper, If you fold that paper and punch a hole through it to distant points, suddenly connect, that shortcut is a wormhole. Could black holes and their mysterious opposites, white holes, form these cosmic tunnels? Could a black hole be an entrance to another universe? Science fiction has explored this idea for decades. From Interstellar to Star Trek, wormholes are shown as highways across galaxies, but reality may be even stranger. If wormholes exist, they may be unstable, collapsing in an instant, or perhaps advanced civilizations could one day harness their power, stabilizing them to travel not just through space, but through time itself. Are black holes gateways or dead ends? The mystery endures. Not all black holes are the same. Some are small, only a few times the mass of our sun, but others are monsters, supermassive black holes, giants, millions, even billions of times heavier than our sun. Where do we find them? At the center of nearly every galaxy, including our own Milky Way. In 2019, humanity captured its first glimpse of one, the black hole in the galaxy M87, an orange, glowing ring, the shadow of a cosmic giant 6.5 billion times the mass of the sun. But how do these titans form? Did they begin as small black holes that grew over billions of years? Or were they born in the earliest moments after the Big Bang? We still don't know. Yet one thing is certain: without supermassive black holes, galaxies themselves might never exist. They may be the hidden architects of the universe, shaping the stars, the planets, and perhaps even life itself. Black holes do not always sit quietly in the dark. When they feed the universe, as gas, dust, and stars spiral into a black hole, they heat up to millions of degrees, forming a glowing disk of energy called an accretion disk. These disks shine brighter than entire galaxies. Jets of particles blast out at near light speed, stretching thousands of light years into space. These active galactic nuclei, also called quasars, are some of the brightest objects in the universe, and at their heart lies a hungry black hole. It is an irony of nature. The darkest objects in existence can also create the brightest beacons in the cosmos. Black holes not only bend space, they bend time. If you orbit close to a black hole, time for you slows down. For the rest of the universe, centuries may pass. In this way, black holes may act as one-way time machines, carrying travelers into the distant future. But could they allow travel to the past? General relativity does not forbid it. Wormholes, if stabilized, might connect different points in time. Imagine stepping into a black hole and emerging thousands of years in the past or future. But the paradoxes of time travel remain. If you could go back, could you change history? Or would the universe correct itself? The answers lie hidden in the darkness. For now, black holes remain our best hope of unlocking the secret of time itself. For centuries, black holes were seen only as destroyers. But in the 1970s, one man changed that vision forever: Stephen Hawking. Hawking proposed something revolutionary. Black holes are not eternal. At the quantum level, strange pairs of particles pop in and out of existence everywhere in space. Near a black hole, one of these particles may fall inside while the other escapes. To an outside observer, it appears as if the black hole itself is slowly evaporating. This is Hawking radiation. That it means black holes have lifespans. Small ones might evaporate in seconds, but supermassive ones, they could take trillions of years to fade away. In the end, the universe may grow cold and empty, as the last black holes release their final breath of energy, before vanishing forever. What role do black holes play in the fate of the cosmos itself? Some scientists imagine a distant future called the black hole era. Billions upon billions of years from now, stars will fade, galaxies will dim, and only black holes will remain. For a time, they will dominate the universe, swallowing the last remnants of matter. But slowly, Hawking radiation will take its toll. One by one, even the largest black holes will vanish into nothingness. This final stage, a universe without stars, without light, without structure, is called the heat death of the universe. And yet, there are other theories. Perhaps black holes could trigger new big bangs. Perhaps each black hole births an entirely new universe. If so, then our universe itself may have been born from the collapse of another. A cycle without end, a chain of universes. linked through the darkness. Not all black holes are the same size. Some are small, just a few kilometers across. Others are monsters beyond imagination. One of the largest ever discovered lies in the galaxy Holmberg 15A. It is so massive, it contains the weight of 40 billion suns. Its event horizon could swallow our entire solar system. Think about that. A single black hole, larger than everything we've ever known combined, and there may be even bigger ones, still unseen, lurking in the shadows, waiting to be discovered. Black holes have long captured our imagination, not just in science, but in art and cinema. Movies like Interstellar brought them to life in stunning realism. Its black hole, Gargantua, was so accurate that it inspired real astrophysical research. Other films and shows have imagined black holes as cosmic weapons, time portals, or even gateways to other dimensions. But the truth is both stranger and simpler. Real black holes are silent, invisible, and patient hunters. They do not chase spaceships or swallow galaxies overnight. Instead, they wait, in the shadows, for billions of years, and perhaps that silence is what makes them truly terrifying. So what are black holes? Are they cosmic monsters, devouring everything in their path? Are they engines of creation, building galaxies and shaping the stars? Are they portals to hidden universes beyond our imagination? The truth is, we still don't know. Every black hole is a riddle wrapped in darkness. Every discovery brings us closer to understanding, yet reveals even deeper mysteries. The idea of black holes is older than you might think. In 1783, an English natural philosopher named John Michell proposed the idea of dark stars, so massive that not even light could escape. In the 20th century, Albert Einstein's theory of relativity gave new life to the idea. In 1939, Robert Oppenheimer, the same man later known for the atomic bomb, predicted that collapsing stars could form what we now call black holes. Yet for decades, scientists dismissed them as mathematical oddities. It wasn't until the late 20th century, with the discovery of strange cosmic X-ray sources, that the reality of black holes could no longer be denied. And today, black holes are not only accepted, they are celebrated as one of nature's most mysterious creations. Black holes cannot be seen directly. They trap light itself. So how do we study them? Astronomers use clever methods. They watch how stars move. If a star orbits something invisible, but heavy, chances are it's a black hole. They observe X-rays created when matter spirals into the abyss. And in 2019, for the first time, they captured an image of a black hole's shadow using the Event Horizon Telescope, a network of radio dishes spread across Earth. It was a triumph of human collaboration, scientists across continents working together to glimpse the unseen. The black hole image was just the beginning. The James Webb Space Telescope is already peering deeper into the cosmos, studying galaxies and their hidden black holes. Future projects, like the Einstein Telescope and the Laser Interferometer Space Antenna LISA, will detect gravitational waves, ripples in spacetime from black holes colliding. With each discovery, our picture grows clearer. Perhaps one day, we may even send probes near the event horizon, robotic explorers built to withstand unimaginable forces. And who knows, maybe humanity's greatest discoveries still lie in the shadows of black holes. What if we are not alone? Some scientists speculate that advanced civilizations might use black holes as energy sources. By capturing energy from the radiation around them, aliens could power entire planets. Others wonder, could aliens travel through wormholes created by black holes? If so, then the black holes we see in the sky might not just be cosmic monsters. They might be doors, used by others long before us. The thought is chilling and inspiring. And so, after 4 hours of journeying into the heart of darkness, we are left with more questions than answers. What are black holes? Where do they lead? And what do they tell us about the nature of existence itself? For now, the truth remains hidden, but as we keep reaching further into the cosmos, one day, we may uncover the final secret of the universe's darkest giants. One of the greatest mysteries is the information paradox. According to Einstein's theory of relativity, once matter falls into a black hole, it's lost forever. But quantum mechanics insists that information can never truly disappear. Which is right? Einstein or quantum theory? This paradox has led to bold ideas, from firewalls at the event horizon to holographic principles suggesting that our universe itself is just a projection, like an image on a cosmic screen. Could it be that black holes are showing us that the very foundation of reality is not what we think? If black holes warp space so intensely, could they also warp time itself? Some physicists argue that black holes may hold the key to the beginning of time, perhaps even the Big Bang. Could our entire universe have been born from a collapsing black hole in another universe? If so, then every black hole we see could be a seed, a cosmic womb, giving birth to new realities beyond our comprehension. This raises a haunting question. Is our universe just one branch in an endless forest of multiverses, each one sprouting from the dark heart of a black hole? Galaxies themselves seem to revolve around supermassive black holes. Without them, stars might drift apart, galaxies might never form the way they do, and the night sky we admire could look utterly different. Could it be that black holes are actually sculptors of cosmic architecture? Up until now, we've looked at black holes as monsters of the cosmos, terrifying devourers of stars and planets. But what if we change our perspective? What if black holes are not destroyers, but builders of structure in the universe? In the far future, black holes will be the last giants standing. As stars fade, galaxies die, and the universe grows cold, only black holes will remain. But even these titans are not eternal. Slowly, over unimaginable timescales, they will evaporate through Hawking radiation, shrinking into nothingness. This is the ultimate fate. A universe filled with darkness, silence, and the ghosts of vanished black holes. And yet, within this bleak destiny lies beauty, because everything we are, every atom, every star, every memory, may one day return to the quantum sea of energy. The end may not be an end, but a transformation. So what are black holes, really? Are they destroyers? Or gateways? Are they the ultimate mystery, or the key to understanding all of existence? The truth remains hidden deep within the event horizon. But one thing is certain: to study black holes is to study ourselves, our origins, our future, and our place in the infinite cosmos. And perhaps one day, with courage, curiosity, and science as our guide, humanity will step closer to unveiling the dark secrets of black holes. If this cosmic journey fascinated you, make sure to subscribe to our channel for more deep explorations of the universe. Stay curious, stay inspired, and never stop looking up at the stars.